On March 14, 2024, a routine sky survey flagged 31 Atlas as just another near-Earth asteroid. But within 8 months, it displayed behavior that no natural object should exhibit: a deceleration pattern, 11 spectroscopic impossibilities, and a trajectory adjustment that defied orbital mechanics. Quietly, NASA reclassified it from routine monitoring to continuous observation. The UN Space Affairs Office convened 3 emergency sessions in 6 weeks. If 31 Atlas is just a rock, why did the response escalate from academic curiosity to coordinated global surveillance? And what are the models predicting that officials refuse to publish? The public story remains calm and measured, but the actions behind closed doors reveal something closer to alarm. So what really started when 31 Atlas stopped behaving like an asteroid? The first detection of 31 Atlas came at 2:47 a.m. Greenwich Mean Time on March 14, 2024. The Atlas Survey Telescope in Hawaii registered a magnitude 19.8 object moving through the constellation Virgo. Within 36 hours, follow-up observation from Pan-STARRS, the Catalina Sky Survey, and the European Space Agency's optical tracking network confirmed its existence and preliminary orbit. The numbers looked unremarkable at first. 31 Atlas measured approximately 340 meters across, placing it in the mid-sized category for near-Earth asteroids. Its orbit was classified as Apollo type, crossing Earth's path with a semi-major axis of $1.52 and an eccentricity of 0.41. The inclination was moderate at 8.3 degrees. By every standard metric, this was a textbook space rock, one of roughly 34,000 cataloged near-Earth objects tracked by planetary defense networks worldwide. The Minor Planet Center assigned it the provisional designation 2024 FE7. The Atlas team, following their discovery protocols, requested the informal name 31 Atlas, marking it as the 31st significant object their network had characterized that year. Initial impact probability calculations gave it a Torino scale rating of 0, meaning no hazard. Its closest approach to Earth would occur on November 8, 2024, at a distance of 18 cents, roughly 27 million kilometers, about 70 times the distance to the Moon. Through March and April, 31 Atlas drew minimal attention. Observatories logged its position, refined its orbital elements, and moved on. The object exhibited a rotation period of roughly 7.2 hours based on light curve analysis from the Lowell Observatory. Its albedo, the measure of surface reflectivity, came in at 0.14, consistent with carbonaceous or C-type asteroids, among the most common in the inner solar system. Spectroscopic data from the Gemini North Telescope showed absorption features matching hydrated silicates and organic compounds, unremarkable signatures for this class of object. But on May 2nd, something changed. A team at the Keck Observatory in Hawaii captured a high-resolution spectrum as part of broader asteroid composition survey.
Right here. That spike
the
is
data
within the
showed
acceptable
the expected
error
silicate
margin,
bands.
Elena. The blue
It
trend
also
is
showed
accurate.
something else. A narrow emission line at 589.3 nanometers, the wavelength of sodium, appeared far brighter than it should. Sodium is common in asteroids, but emission at this intensity typically requires either intense solar heating or active venting of material. 31 Atlas was still $1.40 from the sun, too far for thermal models to explain the signal. The team flagged the observation as anomalous, but did not yet sound any alarms. Over the next 2 weeks, 3 separate observatories, Apache Point in New Mexico, the Subaru Telescope in Hawaii, and the South African Astronomical Observatory, independently detected the same sodium emission. Each measurement confirmed the others. By mid-May, the object had a reputation among asteroid researchers as the sodium problem. Papers were drafted. Hypotheses circulated. Some proposed recent impact excavation. Others suggested subsurface ice venting through fractures. None of the models fit perfectly. Then, on May 29th, the European Southern Observatory's Very Large Telescope in Chile recorded a sudden drop in 31 Atlas's brightness. Over a span of just 14 hours, its magnitude dimmed by 0.8, a massive shift for an object that should have remained stable. When brightness returned to baseline 19 hours later, the sodium emission had doubled in intensity. whatever was happening on or inside 31 Atlas. It was active, variable, and defied easy categorization. By June, 31 Atlas was no longer just another asteroid. It was a puzzle demanding answers. Across 5 months, 31 Atlas became a catalog of contradictions. Each new observation added another piece that refused to fit the standard asteroid profile. The data was precise, reproducible, and deeply strange.
We have a trajectory deviation on Atlas 31. The amber light is active.
The Arecibo planetary radar system, before its decommissioning, managed a final high-power observation of 31 Atlas. The radar return showed surface roughness consistent with rubble pile asteroid, a loose aggregate of fragments held together by weak gravity. But embedded in that return was a secondary echo, a faint reflection arriving 0.003 seconds late. That delay corresponded to a depth of roughly 450 meters, implying a hollow or low-density core. No natural rubble pile exhibits that geometry. On June 24th, NASA's Infrared Telescope facility on Mauna Kea measured the object's thermal emission. Surface temperature read 220 Kelvin, exactly as predicted for its distance from the Sun. But localized hot spots, each no larger than 10 meters across, glowed at 340 Kelvin. The pattern suggested internal heat sources, not solar warming. Asteroids do not generate their own heat. By early July, spectroscopic teams had detected multiple compositional anomalies in 31 Atlas. Potassium emission appeared alongside sodium, but at a ratio of 3.7 to 1, far higher than any measured asteroid. Calcium lines flickered in and out of detection over just days, as if material was being exposed and then covered. A faint absorption feature at 3.4 microns hinted at complex organic molecules. But the depth of the band exceeded anything seen in carbonaceous chondrites. On July 19th, the Hubble Space Telescope captured the first resolved images of 31 Atlas. The object was not a single body. It appeared as a tight cluster of at least 7 distinct components, each between 40 and 90 meters across, separated by gaps of just 20 to 50 meters. The formation rotated as a coherent unit, maintaining precise spacing. Natural asteroid families, fragmented from ancient collisions, do not hold formation like this. Gravitational dynamics scatter them across millions of kilometers within centuries. This cluster had been together, stable and organized, for an unknown length of time. On August 3rd, a team at the Parental Observatory in Chile recorded a sudden burst of ultraviolet emission.
This data contradicts everything we projected. Look at the spike
right here.
The event
lasted only 11
within
minutes,
the acceptable
but released
error margin,
energy
Elena.
equivalent
The
to a
blue
small
trend is
solar
accurate.
flare. UV bursts from asteroids are unheard of. The emission spectrum matched ionized oxygen and nitrogen, gases not naturally present on airless bodies. Mid-August brought the first dynamical anomaly. The Jet Propulsion Laboratory's Horizon system, which models solar system orbits with extreme precision, began reporting residuals in 31 Atlas's trajectory. The object was not where it should be. The deviation was small, just 320 kilometers over 2 weeks, but it was real, measurable, and growing. Non-gravitational forces, outgassing, solar radiation pressure, typically affect comets, not solid asteroids. 31 Atlas showed no coma, no tail, no dust, yet something was altering its path. On August 27th, the deviation became undeniable. 31 Atlas had decelerated. Its velocity dropped by 0.004 kilometers per second, a tiny amount in absolute terms, but enormous in implication. Objects in space do not slow down unless acted upon by an external force. Drag requires an atmosphere. Magnetic braking requires ionized plasma and a magnetic field. Neither existed here. The deceleration was smooth, continuous,
this data
and targeted,
contradicts everything we
as if
projected.
something was
Look
gently
at the spike
applying
right here.
thrust in
That
reverse.
spike is within the acceptable
September
error margin,
observations
Elena.
from the Keck
The blue trend is accurate.
revealed further rotational oddities. The original 7.2-hour spin period had shifted to 7.05 hours, a 2% change over just 4 months. Spin changes happen when asteroids shed mass or experience torque from outgassing jets. 31 Atlas showed neither. Its rotation was speeding up without visible cause. On September 14th, the Vatican Advanced Technology Telescope in Arizona part an international monitoring campaign. detected polarized radio emissions from 31 Atlas at 1.4 gigahertz. The signal lasted 8 minutes, repeating twice over a 6-hour window with identical structure. Natural radio emission from asteroids are vanishingly rare and never polarized. The team submitted their findings to the International Astronomical Union with a note of deep concern. By late September, the anomaly count reached 11, sodium emission far beyond thermal limits, secondary radar echoes suggesting hollowness, localized thermal hotspots, extreme potassium to sodium ratio, flickering calcium lines, deep organic absorption bands, multi-body cluster geometry, UV burst emission, measurable trajectory deviation, continuous deceleration, accelerating rotation, and polarized radio pulses. Each anomaly had been logged, peer-reviewed, and debated. No unified explanation emerged. The object was behaving less like a rock and more like something under active control. October 8th, 2024 marked the point when observation turned to alarm. On that date, 31 Atlas executed a course correction. The object velocity vector shifted by 0.12 degrees, a subtle change, but one that required approximately 14 meters per second of delta V. The change in velocity needed altered trajectory. For comparison, NASA's DART mission, which successfully redirected an asteroid
Flight,
in 2022,
deviation
imparted
on
about
Atlas 31,
2.7 millimeters per second of delta V by slamming the spacecraft into its target at high speed. 31 Atlas had just achieved more than 5,000 times that effect with no visible propulsion, no exhaust plume, and no mass loss.
Flight, we have a trajectory deviation on Atlas 31. The amber light is
Detailed propagation models from JPL, ESA, and independent teams all converged on the same conclusion. 31 Atlas was now on a path that would bring it significantly closer to Earth during its November approach. Not dangerously close, but closer than original predictions by nearly 4 million kilometers. The adjustment appeared deliberate, calculated to thread a specific orbital corridor. Dr. Alan Fitzsimmons, a planetary scientist at Queen's University Belfast, released a preprint on October 12 titled Non-Gravitational Dynamics of 31 Atlas, Implications for Mission Planning. In it, he argued that the object behavior could only be explained by 3 possibilities: an undetected volatile reservoir venting gas in a highly directional manner, an internal heat source producing sustained thrust through sublimation, or artificial propulsion. Fitzsimmons did not endorse the third option, but he did not rule it out either. His paper called for immediate spectroscopic follow-up and high-resolution radar mapping. Dr. Carolyn Porco, a veteran planetary scientist and former leader of the Cassini imaging team, took a different stance. In an interview with Science magazine on October 18, she stated, "We are looking at an object that defies conventional asteroid physics, but we have seen surprising bodies before. What matters now is data, not speculation. We need dedicated missions, not premature conclusions."
The amber light is active.
Porco emphasized that 31 Atlas could be a natural body with properties we have simply never encountered, a remnant from the outer solar system, or a fragment of a disrupted protoplanet with unique internal chemistry. The debate sharpened on October 21st when a team at MIT's Haystack Observatory published radar interferometry results. Using the technique to map 31 Atlas's surface with sub-meter resolution, they found geometric patterns, flat surfaces intersecting at precise 90-degree angles, edges aligned with rotational axes. The researchers stressed that these could be crystalline structures or impact sculpted facets.
This data contradicts everything we
but the
projected.
precision
Look at
was
the spike
unsettling.
right here.
That spike
Natural
is within the
processes
acceptable error
rarely
margin,
produce
Elena.
such
The blue
regularity.
trend is accurate.
By late October, the scientific community was fractured. One camp insisted that 31 Atlas, however strange, remained within the bounds of natural phenomena, albeit at the extreme edge. Another camp, smaller but growing, argued that the totality of evidence pointed to something engineered, whether recently or long ago. A third group refused to take sides, demanding more data before any conclusions. Public awareness remained low. A few astronomy blogs covered the story. Social media picked up fragments, but mainstream attention had not yet arrived. That would change in early November. November began with a cascade of institutional responses that, individually, might have passed unnoticed. Together, they painted a picture of coordinated concern. On November 2nd, NASA's Planetary Defense Coordination Office, typically focused on impact hazards, issued an internal memo reclassifying 31 Atlas from routine monitoring to continuous observation priority. The memo, later leaked to Space News, authorized 24/7 tracking using assets normally reserved for imminent threats. The Deep Space Network allocated dedicated time slots for radar tracking. Hubble's observation schedule was quietly adjusted to include additional passes. On November 4th, the European Space Agency convened an emergency session of its Space Situational Awareness Program. Attendees included representatives from 22 member nations, officials from UNUSA, the UN Office for Outer Space Affairs, and liaisons from the U.S. Space Force and Russia's Roscosmos. The session was closed to the press. A brief statement afterward referenced enhanced tracking protocols for dynamically evolving near-Earth objects. No mention of 31 Atlas by
deviation
name.
On Atlas
On
31,
November
the amber
6th,
light is
the
active.
International Asteroid Warning Network,
Reroute auxiliary
a coalition
power
of space agencies and observatories coordinating planetary defense efforts, activated Protocol 7, a designation reserved for objects exhibiting unpredictable
Flight, we
behavior.
have a trajectory deviation
Protocol
on Atlas
7 had been
31,
invoked
the amber
only
light is
twice
active.
before,
Acknowledged.
both times for
Reroute
comets
auxiliary
showing
power now.
explosive fragmentation. The activation triggered automatic data sharing agreements, classified sensor integration, and priority access to military tracking platforms. Japan's JAXA, which operates the Hayabusa asteroid sample return missions, announced on November 7th that it was fast-tracking a feasibility study for a rapid reconnaissance mission to a near-Earth object of scientific interest. The timeline proposed launch readiness within 18 months, an unprecedented schedule for a deep space mission. No target was named, but mission parameters matched 31 Atlas's orbit
Look
with
at the
eerie
spike
precision.
right here.
That spike
China's
is within
National
the
Space
acceptable error
Administration,
margin, Elena.
typically
the blue trend
reserved
is
in its public
accurate.
communications, issued a statement on November 9th committing to expanded near-Earth object observation capabilities and pledging cooperation with international partners. Satellite imagery analysts later noted increased activity at China's deep space tracking stations in Kashgar and Chitai. On November 10th, the U.S. House Committee on Science, Space, and Technology held a closed-door briefing on planetary defense readiness. 2 days later, the committee quietly approved a $480 million supplemental funding package for NASA's Near-Earth Object Observations program, more than doubling its annual budget. The bill passed with bipartisan support and minimal public debate. Behind the scenes, a more subtle shift was underway. Classified space surveillance assets, typically used to track satellites and space debris, began devoting time to 31 Atlas. The U.S. Space Surveillance Network logged hundreds of observation passes in the first week of November alone. Signals intelligence platforms designed to detect electromagnetic emissions from spacecraft were tasked with monitoring the object for any transmissions. None were officially reported, but the fact that the search was conducted spoke volumes. For 2 weeks, the global space community operated in a mode somewhere between
This
scientific
data contradicts
campaign
everything
and
we
crisis
projected.
response,
Look at the spike right here.
That
mobilizing
spike is
resources,
within the acceptable error
synchronizing
margin, Elena.
observations,
The blue trend is
and preparing
accurate.
contingencies for an object that officially posed no threat. Speculation about unknown objects and hidden technologies has a long history. Stories about unidentified aerial phenomena, recovered materials, and government secrecy have persisted for decades, shaping how people respond when science encounters something it cannot immediately explain. In the case of 31 Atlas, these narratives surface again, threading through online forums, fringe documentaries, and even some academic discussions. Some see patterns in the data and wonder if this is part of a larger, undisclosed picture. The tight cluster geometry, the deceleration, the radio pulses,
we have a trajectory
each becomes a
deviation
data
on
point in a
Atlas 31,
speculative
the amber light
framework
is
built
active.
on decades of
Acknowledged.
UAP reports
Reroute
and
auxiliary power
whistleblower
now.
testimony. But patterns are not proof. Correlation is not causation. The scientific method demands evidence that can be tested, repeated, and verified,
Flight, we have a
not just
trajectory
intriguing
deviation on Atlas
coincidences
31,
or
the amber light
resonances
is
with
active.
past claims.
Acknowledged.
For now,
Reroute auxiliary power
the only
now.
certainty is that 31 Atlas is raising questions that current models cannot answer until the data provides clear, reproducible evidence. Every extraordinary claim remains exactly that, a hypothesis awaiting confirmation. The next round of observations will matter far more than any historical echo or unverified story. November 8th, 2024 is the moment of truth. On this date, 31 Atlas makes its closest approach to Earth, passing at a distance of approximately 23 million kilometers.
This data
is close enough for every
everything we
major
projected.
telescope,
Look at the spike right
radar
here.
That
system,
spike
and
is within the
space-based
acceptable
observatory
error margin, Elena.
to focus
The blue trend is
simultaneously on
accurate.
a single target. NASA's Goldstone radar facility will conduct continuous tracking for 72 hours. The Hubble Space Telescope will capture multi-wavelength imaging every 6 hours. The James Webb Space Telescope will perform infrared spectroscopy to search for thermal signatures and compositional clues. Ground-based observatories across 6 continents have coordinated a global observation campaign, ensuring that 31 Atlas remains under watch as Earth rotates. Amateur astronomers have organized their own networks, pooling data through online platforms and contributing to the global dataset. Universities, research institutions, and independent scientists are calling for full transparency, immediate release of all findings, and open peer review. The public is demanding answers. November 8th is not just a flyby. It is a test of our instruments, our models, and our willingness to confront what the data reveals. Whatever that may be, the numbers will speak. The question is whether we are ready to listen. Right now, space agencies worldwide are operating as if 31 Atlas is more than just a rock. Whether driven by caution, curiosity, or genuine concern, the response has been unprecedented in scale and coordination. The line between scientific inquiry and strategic preparedness has blurred. Decisions are being made in closed meetings, with incomplete data and mounting pressure. The sky is no longer a passive backdrop. It is an active frontier, one that demands attention, resources, and honesty. Are we ready for what follows when the unknown stops being theoretical? Let me know what you think in the comments below.